In this video, I'm going to show you how to diagnose your car or truck, your AC compressor, to determine if it's faulty, bad, or not 100%, because nowadays it's very easy to misdiagnose a compressor. Times have changed, and if you want to know my credibility, I worked in a automotive AC shop from the years 1992 all the way up to 2008, and prior to that I worked in the HVAC industry, residential and commercial, so I've got a lot of background in air conditioning in general. But I'm going to show you how to diagnose a compressor. And I mean absolutely diagnose it to where there is no misdiagnosis, because the problem I'm going to show you, there's multiple things that can cause this problem. And back in the old day, with the pressures I was getting off this car, I would have said compressor. No ifs, ands, and buts about it, and it very well could be a compressor, but I've got to prove it. So I'm going to walk you along. I'm going to show you exactly how I'm going to make that determination once and for all. So I had this car over here about 4 days ago just to do a quick check and see what I could find. And so I hooked my gauges up to this car and I made sure both valves were closed. And what I was reading was a very high low side pressure. That's your low side. It was high. It was almost equalized with the high side. Car is not running right now. This is just static pressure. But I had my wife come out here and I had her get into it a little bit, into the throttle, and I started getting some pumping on the low side and the high side, but not near enough. I think I was pulling down close to 60, and this suction line went from a warm line, almost ambient warm. It was starting to sweat and cool off a little bit just from it being able to pull down to 60 degrees, but that's not near enough. So anyway, I'm instantly thinking compressor. And the only other thing that could create pressures like that, well, one of them, if you forget to close these valves, if both of these are on, you're going to be reading that pressure. But that's not the problem, obviously. But the expansion valve is back behind here, and if it gets stuck open, it will also give you a higher low side and a lower high side. So I knew that wasn't a problem, because this line here, the suction line, like I said, it was warm and it started cooling off somewhat once we got into it. If this thing had a stuck expansion valve, it would be dumping way too much refrigerant into the evaporator, to the point to where it's going to boil off anyway. Just the fact that it goes from a smaller liquid line to a bigger line here, the evaporator is bigger, and there is going to be frosting out here on this line, and the frosting would probably go all the way down to the compressor itself. Was not doing that, so I was calling compressor. Back in the old days, I would have instantly just said, you need a new compressor. You know, and of course when you do a compressor, you end up changing out the dryer, the filter dryer, and the expansion valve. Or if it's an orifice tube type system, you would change out the accumulator and an orifice tube. This is filter dryer and expansion valve. So if this ends up being a compressor, then I will definitely need a compressor. I will need a filter dryer and an expansion valve to complete this job. And here's another caveat about this particular car. This car has a newer style condenser. It's more like a micro channel. They cannot be flushed out, and the dryer cannot be removed. It's permanently affixed to the condenser. So in order to change the filter dryer to where we get a warranty on this compressor, that entire condenser has to be changed out. So that, I'll tell you what, that's the world we're living in now. Used to be you could just undo a dryer over here in the system somewhere off the liquid line and replace it and flush out your condenser. Not anymore. Those days are over. So back to my point, today's compressors are computer controlled. They're controlled by the ECU, or if you want to call it an ECM, it's the same thing. Exact same thing. It is all controlled by that. You have a ton of different sensors that sends input back to the compressor, and it determines what duty cycle to give this compressor depending on demand. If it's just a cool day out and just a little warm sun coming through, it's got enough sensors to tell it to just run it like at 50% or 40%. If it's a 95-degree day and the sun's blaring, it's hot outside, high humidity, it's got sensors that don't tell the computer to run this compressor at 100%. And now if you're looking at this tool right here, that's exactly what it does. It's the only one I know of. A scanning tool, like a bidirectional scanning tool, will not do what I'm going to show you. But this will absolutely prove 100% if this compressor is bad due to a computer hiccup, an issue with the computer, or if in fact it's just simply wore out. So we're going to do that here right now. I've already got my gauges hooked up, as you've seen. I got it valved off, both sides, high and low side, and that's just static pressure, nothing's running. But before we can start this car, the first thing we need to do is hook power up to this electric control compressor tester. The directions with this tells you to hook up the negative side first. This looks like a good place to me for a negative. Right there. Then we're going to hook up the positive. So if you'll notice this light, this green light is flashing, that's only because the key is off. Now if this car was up and running and if this was flashing, this tells you automatically you're getting no kind of PM or PWM signal from your computer to control the valve. And really you would not even need to go into the tool itself. This would tell you all you need to know, that you got a computer issue. There would be no PWM signal, which is a pulse width modulation. That's how it's able to control this little motor on this actuator valve on the back of the compressor. It's done through pulse width. It's pulsing voltage to it at a slower rate or a higher rate depending on how much duty cycle you want on that valve. But enough of that, let's go ahead and fire it up and let's do this test. All right, my AC is engaged. First, let's take a look at our pressures here. As you can see, it's just like I said, you see it fluctuating a little bit, but I'm running about 75 pounds on my low side and a little over 100, 120, 25 on my high side. That ain't near about good enough. So let's take a look at the tool itself. Now look at there, that's actually reading what the computer is putting into it. It's putting right at 90% duty cycle. That already tells me that we have a faulty compressor, not a computer problem. Now I can check the resistance on this valve to see if it's in range. It should be between 10 or 14 ohms. All right, we got 13.3, we're still in range. I can go into manual mode and I can bring this up manually. Let's go ahead and bring it all the way up. I think it'll let it go up to 84% in manual mode. See there? Same thing, just isn't pumping. So when you go into manual mode, that is actually bypassing the computer and you are controlling that valve completely manually. Now we're back in normal mode, 89.5, right at 90%. So this compressor is definitely bad, no doubt about it. Also, I meant to say, when my wife got in here and revved this up the other day, this compressor was chattering. It was making a noise. That kind of told me already, but I had to prove it. I absolutely had to prove it. And so, you know, if you end up getting one of these tools, on some models, it will take out the condenser fan. It will turn it off when you go into manual mode. So if you do this test, you have to do it quickly so you don't run your head pressures up. In my case, it's not hardly pumping, so no big deal, and my fan is operating. I'm feeling of it now. It is operating, so we are good. All right, I possibly could get some comments off this video that you can check the duty cycle on what the computer's telling that control valve what to do, you know, and you absolutely can use a multimeter. Here is a Fluke multimeter, and if you look right here, it says hertz, but it also has a percent sign. That percent sign is duty cycle. Now you can read the duty cycle right here on your screen, what percentage it's at, but the only difference between this and the other one that I showed you earlier is that the other one will let you bypass the computer and do it manually. Let's just say I had a bad sensor that was telling the computer to give it 20% duty cycle on a very hot day. Well, it's going to show that it's getting duty cycle. That's fine and dandy, but why is it only giving it 20%? That would automatically make you think bad sensor, whether it be an ambient temperature sensor, a cabin sensor, thermistor, you got high and low pressure, transducers. Any of those can cause that problem. So by me being able to take the other tool and disconnect, take the computer completely out of the equation, and then bump up that duty cycle to where you've seen it, 84%, then you can watch your pressures. And that will tell you if all that's working or not. But in my case, as you've seen, it was just simply not pumping regardless if the computer was telling it to or if I did it manually. But I did want to address that you can do some of that with a multimeter. Before I get too deep into this car, I want to go ahead and show you something I've recently received. Now this company reached out to me and wanted to send me a jump starter, so I accepted because I can definitely use one. I bought one, I think it was back in 2006. It was a big yellow bulky jump starters that was obviously a lead battery. This thing had to weigh 30 pounds at least, and I got about 3 years out of that. I used to use it at the same AC shop I mentioned earlier, and we had to use it quite a bit. Cars would come to us sometimes on a wrecker, you know, a rollback or whatever, and a lot of times they had dead batteries, so I ended up wearing that one out. But man, have times changed. Check this little dude out. Now, just for size comparison, now obviously this is way thicker than this iPhone. See if I can get it out of the bag here. Here we go. It's quite a bit thicker, as you can see, but as far as the actual footprint, it's like, how in the world can this little thing jump start anything? But look at the amperage on that, 6,250 amps. Now this is a 12 volt and it's pretty cool. It comes with positive and negative clamps here, and this would take it out again. Right here where these two ports are, right here, that's where that plugs into. Go ahead and plug it up and just show you what it looks like. This plug can only go in one way, so there's no danger of putting it in backwards. And there it is right there. This is fully charged, and as you can see, it's 12 volt ready. This is ready to hook to a dead battery and start your car. This will even start diesel engines. This thing is a little powerhouse to be that small. Now, in addition to being able to charge a battery, you got USB-A and USB-C outlets that you could charge any kind of device, your cell phone, in my case camera batteries, just whatever. So it could be used for that too, but I've got other things I do that with. I'm dedicating this strictly to carry in my car in case we experience a dead battery, which happens a lot. I'm 65 years old, and I can't tell you the times I would either go to work or leave work only to find a dead battery. Something like this would have been so handy to have. Just a flashlight. Get out of here, flies. You can hit it again. Got a little strobe effect. And then that's kind of like an SOS. At night, if you broke down, that would be handy to have. So it also comes with this USB-A to USB-C charger to actually charge this unit. And I think, if I remember correctly, it said to, you know, top this charge off is either 3 months or 6 months. I can't remember exactly. But I tell you what, everybody's got cars. I would highly recommend having this. And I'm glad to get it. And I told them I would mention it in a video, and so that's why I'm doing this. And so, you know, they do have these with higher amp ratings, and some of them actually have an air compressor for airing up your tires. I do have a dedicated compressor that stays in our car for doing that, and this suits all of my needs. All we have is a 2019 Toyota Corolla. It should spin that little puppy over no problem, and I'll have all the links down in the description. All right, it's the next day, and I did get this car back. They went and had the refrigerant recovered from this system. Now earlier I took and removed the condenser, and I just removed the compressor right here, and the next thing I'm going to do is back in here. Let me see if I can get you a shot. There is an expansion valve right back in there. I got to remove it. If you'll take a look at this condenser, if you look to the right, that is the filter dryer. And if you remember, I told you that nowadays on a lot of these models, the filter dryer is actually built into the condenser, and that condenser is like micro channels, cannot flush through it. You got to replace the filter dryer, so you have no choice but to replace the whole thing. That's a brand new one in that box. Here is the old compressor that came out of it, and I'm comparing these. It looks to be the exact same compressor, different brand. This is a sanding compressor, but everything is identical to it. Everything's in the right place. Now, I just want to briefly talk, but before I do, let me say this. The reason I'm not showing you removing this compressor and how to remove it and how I did the condenser and how I'm going to do the expansion valve is that would make this video specific to a certain make and model and year and all that, and that's not what I intended for this video. This video is intended to show you how to properly diagnose a faulty bad compressor, one that's not pumping, and know 100% sure that is the problem. Now, this is the electronic control valve we discussed earlier. Here's the one on the new one. They come with it. Now, I have seen people do videos of this, and some people think, you know, they're told they need a new compressor, and then they watch videos and they see where people have actually just changed this part out. You can buy just this valve if that's your problem, but I have no way of knowing if this valve is like clogged up from microparticles, aluminum, if you will, like a sludge of aluminum that eventually got in this valve and took it out. Me personally, I would never change just this valve without doing the entire compressor, because more than likely, if that's what's wrong with this one, then that's what took it out. If I was to take this out, more than likely I'm going to find metal shavings. Now, there is little screens on this to help prevent that getting into it, but it still makes its way in there. If it's a fine enough powder, the oil turns almost like a silver color. It's going to get in here, but that might not be the problem. There's also valve plates in here. You got exhaust and intake, and your pistons are in here. And I don't remember if I talked about this or not, but the way this works is this valve will apply pressure or take away pressure depending on what position it is. It's an actuator valve, and the computer tells it where to be. So what it does is it takes this swash plate. There's a swash plate in here. Some people call it a wobble plate, and it can actually change its angles, and depending on what its position is what determines the stroke of the piston. Now, if this had 0% duty cycle going to it, this swash plate would be straight up perpendicular to this casing, and that would be no movement on the pistons whatsoever. The more angle you give it, the more stroke the pistons get. So that does control that, and that very well could be the problem is this only, but I don't care. It's getting a new compressor. Any dealership and most shops are going to recommend a new compressor. There might be a few shops that will replace this, but I'm not going to. I'm going to do the whole thing for the reasons I just said. If I put a brand new one of these on an old compressor, it's probably going to be short-lived. If it slugged this thing up, it's going to slug a new one up. So I just had to get that out there. That's my 2 cents worth on that. This job is finished. I got all the parts back on. I flushed the entire system with an AC flush. I flushed the evaporator twice, and then I took and I actually purged it like 3 or 4 times at 120 psi to make sure you don't have any of the liquid flush still inside the evaporator. Did the same thing with the 3 refrigerant lines. It's got a brand new expansion valve, brand new condenser, only because the filter dryer is built onto it. That's just the way things are done nowadays, as we talked about earlier. And it's got a brand new compressor. Now this is not a remanufactured, but it's not OEM products. This was not a Nissan compressor. The one I took off was a Sandin, so I'm assuming that's what Nissan uses. I think that was the original compressor. Wouldn't swear to it, but I think it is. But at any rate, we are blowing ice cubes. I mean, seriously, this thing pulled down to right at 40 degrees, and that's just sitting here idling. If it's running down the road and you got better airflow across the condenser, it's going to do even better. I was running, just sitting here at an idle, 35 psi on the low side, about 225 on the high side, which with the heat we're having out here today, that is perfect, ideal. Now, after I did the flush and everything, and by the way, I took a break overnight, so the system was open overnight. So I got up the next morning, I went ahead and blowed through it again, everything, in case spiders or something like that just happened to crawl into the evaporator or the lines. I wanted to give it one final blowout before I went ahead and put everything together and sealed the system. But once I did get all that reattached, I went ahead and pulled a vacuum, an extensive vacuum. The fact that it was opened up for over 24 hours, and we are in South Mississippi, very humid weather, I wanted to pull a long vacuum, about an hour and a half's worth. So it had a really good vacuum on it. Then after that, we added the refrigerant. I did use some refrigerant scales to where I could put the proper amount. On this car, it says 0.99 pounds. Now that in ounces is 15.84 ounces. That's what I punched in, and that's exactly what's in the car. And I wish I would have showed you this one way to get it all in there. So I'm going to kind of show you right now what I'm talking about. So we're not hooked up to anything. I'm just showing you the gauges. As that Freon is coming in through the yellow hose and it's going into the system through the suction side, this red hose was also hooked up to the car reading the high side. Well, guess what? This is a 6-foot hose and it fills full of liquid refrigerant. So if you don't do what I'm fixing to show you, you're not going to have the full charge in your car. This liquid line is going to be solid refrigerant. I don't know the exact amount. It could be anywhere from an ounce to ounce and a half is my guess. But what you do is you take, once you have this thing fully charged, this is a valve core compressor that hooks to your high side. What you want to do is back that all the way off to where it's no longer depressing the valve. That way it's no longer tied into the car. Do that first. You can leave it hooked up. Just back off of that valve stem. Now once you do that, this liquid that's trapped in here, you want to open this high side up. That's going to dump and equalize pressure between the yellow and this. Then take and open up your suction side, and you can see it. You can see this high side just start falling like a rock. Now it's pulling the refrigerant out of the hoses, and once you see it bottom out, just go ahead and close this off. You don't have to close it off, you're no longer tied into it, but you can close this one off, and then you have all the refrigerant. Now there will be some static pressure left in the gauges. That is just vapor. That is not liquid refrigerant, and when you undo it, you'll hear a psh, and that's it. And that's completely legal. They have a minimus rule with the EPA that if you have to vent a little bit of refrigerant, like psst, it's completely legal. Thought I'd go over that real quick. I wish I'd actually showed it, but man, it's hard to film a video when you're neck deep in a car like this. So I hope you got something from this video. Hope you enjoyed it. Hope you learned something. And if you want to see more specific videos, like for certain models and makes, whatever, let me know in the comments. I will work on cars as I have an opportunity. Like I said, I used to do this full time, and nowadays I just do it for friends, relatives, and things like that. But I haven't forgotten anything, and I can probably teach you a lot if you're wanting to learn. But I hope you enjoyed it. I hope you got something from it. I'm Russ Jones with Skill Savvy DIY.